Hello everyone, this is me, Mehdi Hassan. Welcome to my ninth GIS tutorial. Today we are going to learn how to do flood analysis using interpolation technique. At first, let us see what data we are provided and what we have to do in this task. Here is our question. In here we can see you are given the following special data set with BTM projection for eastern part of Bangladesh. Okay, we have provided a digital elevation model, DEM, of this is a raster file, a fault line, this is a vector file, water level, this is an Excel file, water level, these are some Excel point, not Excel file. Okay, the river, this is a river or water body, this is a vector file, and the Thana boundary, this is also a vector file. So if we see our questions, there is number one question says generate flood map and classify flood as per the FFWC category. This is a standard category. We will classify our flood analysis map reference to this category. And in the second question, we have asked find out the flood statistics for each category. And in third question, we are asked identify the extent and magnitude of flood for each thana and generate statistics. And lastly, in fifth question, we are asked to compose an A4 size map showing the flood extent and magnitude for each upazila of eastern Bangladesh. Okay, let us open our ArcMap. We have just opened our ArcMap. At first, we have to input our data. Our data is here. Okay, I'll input our data. That is name, and then I will input fault line. Okay. After completing our interpolation, we have to go to the raster calculation to identify our area that are flood prone. For that, we will go to the raster calculator. Okay, in raster calculator, we will subtract DEM from the interpolation. Okay. Here is our and we will click OK. So this is our actual flood prone area. We'll name this layer at flood prone area. Okay, flood level. From here we'll name this at flood level. Okay, now we will change this symbology to make it more clear. According to our reference, provided reference, that is said that FFWC category. Okay. To change the symbology, we will double click on this layer and go to the symbology here. From here, we will change its classification. We will select 6 and go to classify. And from here, we will classify this according to our reference. And according to our reference, okay. Then first, this one will be 0. This will be 0.3, then this will be 0.9, then this will be 1.8, and it will be 3.6, and lastly this will be our highest value, that is 10.405, and we will click OK. We can change our level from here. This is our FF, that is not flood affected, and this is our F1, very few area that is flood affected, and this is our F2. F1 F2 means the higher area, that or higher portion of those areas that are flood affected or under the flood level. F3, and this will be F4, and lastly this will be F5. Okay, we'll click OK. Okay, we have just classified our flood level. I will change the color also. I think this will look good. If I click OK. Okay, this FF area indicate that these areas are not flood affected. We'll change it into white totally. Let's change it to the white. Click OK. We'll unmark all our other layers. because we have done those layers. So from here we can clearly see where which areas is more affected and which is less, and this white area doesn't affected by flood, and the color is deeper, the affected area or the affected vulnerability is more. For further analysis we will go to the reclassify to make an attribute table in this layer. We'll go to the reclassify. Okay, we'll select our flood level data in input raster, and then we will classify again as our given reference, that will be 0, 0.3, then 0. Then it will be 0.9, then 1.8, then 3.6, and lastly the value will be the highest value here. Okay, we'll click our OK. Okay, now in output raster we'll save it as reclassify. Now okay, we'll click OK, close. So this is our reclassified flood level area. So this is our reclassify flood map and the symbology. So now the symbology doesn't matter. We are doing this for our calculation. We will go to our attribute table from here. Now we can see there is a row with a value and a count. The value indicate the area, that is FF, F0, F1, F2. That means the vulnerability or the impact of flood on this area. So we'll give a flood status here, and for that we'll add a new field, add field, and this is flood status, and this will be a text, and we will add another field that will be area, and it will be in square kilometer, and we will type the data type as double, and then we will fill, and then we will add another add field. This will be percentage, and it will be flood. Click OK. Okay, now in flood status we have to edit this. For for this we'll go to the editors. Here in editors we'll click start editing. We'll select the reclassify flood level, that is here. From here we'll give it the flood status, that is first one is FF, then the second one is F0, third one is F1, fourth one is F2, fifth one is F4, and the last one is F5. Okay, from area in calculating the area in square kilometer we need to. So now to calculate our area in square kilometer, we will go to the field calculator and select our count, discount, and multiply it with the cell size, because this is a raster image. So the area will be the multiplication of its cell size and the total number of cells, that is count. Okay, we'll multiply it with the 300 because the cell size is 300 into 300, and click OK. So this is our area in square kilometer here. Now we'll calculate the percentage. Okay, before calculating the percentage, we have the correction here. We'll go to the field calculator again, and now we have determined our area in square meter. We have to determine it in square kilometer. For that, because we have the data we are given, the den that was in meter, to make it in to found the area in square kilometer, we have to divide it by 1000 twice. So we'll divide it by 1000. We can divide it by 1000, or we can just simply divide it by 1 and 6 zeros. If you click OK, so this is our finally area in square kilometer. So now for calculating the percentage, we will go to the area in calculator, area in square kilometer, and go to statistics and copy the sum here. Copy the sum. Then we will go to the percentage area and go to the field calculator. Now from here we will select the area in square kilometer, then multiply this with 100, and ultimately divide this whole number with the sum, and click OK. So this is our percentage, and that indicates what is the percentage of the area that has a status of FF, F0, F1, F2, F4, and F5. Okay, and with the calculation of this area in square kilometer and the percentage, our basic statistics calculation is done, that is asked in our question. And here the flood statistics for each category. Okay, now we will move in the number 3 question, that is identify the extent and magnitude of flood for each thana and generate the statistics. For that, we have completed our primary statistics, and now if we want to show our statistics according to the thana boundary, we have to intersect this reclassify layer with our thana boundary. At first, let us import our thana boundary from here. This is our thana boundary. Okay. For intersecting the thana boundary and the reclassify, we have to at first make this raster map into a raster file into a vector file. For that, we will go to the select art toolbox and search for raster to polygon conversions. Okay, and now in input raster, we'll select this reclassify, and in field we'll select flood status. Okay, and now we'll select our output folder here and give it a name, that is poly flood. Click save and OK. Okay, there was a problem with our name. Okay, we name it at raster to poly. Okay, now we are done. We have converted this raster layer into a poly layer. Okay, now we can intersect this with the thana boundary that is here. This is our thana boundary. Okay. Okay, now we'll intersect our thana boundary with the raster to poly, the shapefile. Okay, we'll drag down it in the upper layer. Okay, just open it. We will go to the geoprocessing and we go to the intersect, and doing this there will be raster to poly input feature and the thana boundary here, and we will name it as intersect raster intersect thana boundary. Okay, we'll click OK. So our intersection is done here. Close it. Now if we open our attribute table of intersect thana, okay, from here we can see the shape area is doesn't showing. This is the thana and the thana area here in area in square kilometer. To find out the actual area, we have to add a field from here. Add field. We'll name it as area in square kilometer, and select this as double. Okay. Okay, we have to change this name. Give it a 2 and click OK. Now select this and go to the calculate geometry and just select our unit, that is square kilometers, and click OK. So this is our area in a square kilometer. Okay, now we'll select all the attribute table here and copy this, copy the selected, and go to our Excel file, open a new workbook and paste it here. Okay, here is our data. We'll go to the insert and insert a pivot table here in our new workbook. Okay. Okay, now to calculate the percentage, we'll use the thana name in columns. And here in flood rows we will select flood status, and in values we will select area in square kilometer. We will change it to percentage. We will change it to percentage of grand total, because we want to show the flood affected area according to the total area of a thana. Okay, we'll click OK. So this is showing us that the flooded affected area in every category, that is FF area in a thana here, and F0, F1, F2, F4, F5, and these are the thana name. Okay, and these are the grand total of this thana. Okay. Okay, to make it more clear, we can just club this to layer in column and rows. We can give the thana name in rows and flood status in column. Okay, so this is showing us the whole total area as 100%, and if we change it to the thana reference to thana, that will show that thana area at 100%. We will select here, go to value field, and go to percentage, and select as percentage of row total. Okay, now every thana is here showing the 100%, because we are wanting to see the area that are flood affected in various category according to every thana. Okay, so this is the question of our this is the answer of our third question, that is said identify the extent and magnitude of flood for each thana and generate statistics. So in our question number 4, we are asked to show settlement under various flood categories. For showing this, showing settlements under various flood categories, we have to intersect the BGD settlements with the here raster to poly layer. Okay, we'll go to the geoprocessing and select intersect, and drag it here, and our raster to poly. Okay, so our intersection is done. We'll close it. Okay, we'll name it as settlement flat from here properties to for our better understanding. We click OK. Okay, after doing intersection, if we open our attribute table, here we got the FID of BGT settlement of 2013, and as well as we got the flood status. In our question, if we see it, we need the settlements under the various flood categories. So we got the categories and the settlements. So we'll select hold the attribute table here, and select copy the selected, go to our Excel, open a new sheet, and paste our data here. And from insert, we will insert a pivot table. Okay, now in our rows we will select the flood status here, and in our values we will select the FID BGT settlement. Okay, now we can see and tell that how many people actually living in the flood prone area in various category. There is a huge number of people living in the area that is not affected by flood, and some portion of people are living in a very highly flood affected area. And now in finally we have just shown the show settlements on the various flood category and done with our question number 4. And finally, in our question number 5, we are asked to compose an A4 size map showing the flood extent and magnitude for each upazila of eastern Bangladesh. Okay, for this, we go to the arc map again. For making our map, we have to more clear our thana boundary from here. This is a thana boundary. We'll make it hollow and make a clear outline, make it little thick, and click OK. So this is our thana boundary. We'll drag it up. Here you can see our thana boundary of this our other layers. This is our thana boundary, clear thana boundary. Okay, this is our thana boundary, and this is our flag level. And now if we produce a map one by one for the each thana boundary, it will take a lot of time for us because there are almost there are 72 thana in this map. For that we will use another tool, that is we'll input it here, that is data driven page. This is our tool, that is data driven page. Into the data driven page, setup data driven page here. Okay, we'll enable the data driven page here, and this will be layers, and from layer it will be thana boundary. The name field will be thana name, and sort field will be FID, and click OK. So now as we want to generate a map, we have to go to the view, in the layout view. Okay, as well as we have to insert a insert map. For that we will insert a new data frame here, and add our thana boundary here also. This is a thana boundary. We'll insert it. Thana boundary, we'll insert it here in new data frame. Okay, we'll make it change its symbology as well. Make it hollow. Make it little thick. Click OK. Now we will adjust our insert map here. Okay, and the symbology is not clear. We'll change the color. After we do okay, yellow, and the outer line will be yellow. Click OK. So this is more clear now. We'll again select this and click. At first we will have to select open our activity table. Sorry, we have to go to the thana boundary here and open our activate table. Let us select a thana. Let's see, we have selected this thana, and now we'll click on thana boundary. We will zoom to the selected layer. From here selection, and zoom to the selected layer. Okay, this is more clear now. We have to fix it a little bit. For that we will zoom out it. From here, after this we will click zoom to layer. Now this is showing more properly. Okay, we have to done one more step. Now if we want to show this thana in our insert map. Okay, first let me select my selection, insert map. For that we will right click on it, go to properties. To show the this thana in our insert map, we will go to the data frame properties from here. Okay, go to the extend indicators and select layers here, and mark this show leader, and use simple extend and click OK. Okay, now we can see in our insert map this is showing the location of this thana, but this is not still here. We have to add the level. For that we will go to the thana boundary and click on level features. Now we can see this is the Ajmirganj, and this is the location in the insert map. Now if we, this is already now we want to show the thana name in the above. For that we will go to the page and data driven page name, that is here. We'll take it here and make it more bigger. I'll go to the change in the symbol, change the font, it is Arial black, and size will be, let's say I want it 24, and change this color into, let's say I want to, this is blackish red. Click OK, then click apply. So this is our okay. So this is our name of the thana. So we are ready to export our map. I'll fix this little bit. Okay. Now I also want the page number. For this, we'll go to the data driven and select page number. Where is our page number? I'll go to the properties of this page number. Double click on it, text, and change symbology. Uh, it will be Arial. I will change the size and the color. I will select a dark color and click OK. Apply. Okay. So this is our page number. I'll move it a little bit apart. So this is our page number. Now we are ready to print our map. For that, we will go to the file and go to the page and print setup. From here, size we will select A4 because we are asked to print our map in A4 paper. Okay, click OK. We have to adjust it a little bit. The thana name little higher and the page number. Okay, our page setup is done. Now we are ready to export our map. For that, we will go to the file and go to the export map. From here, we will export it as PDF. Okay. From here, we'll give it a name, that is map thana. Name it as thana map. Okay. Now if you see carefully, if you export this map, this will only print this will only export one map. To export all three maps, we'll go to the format, we'll go to the page and select all 72 map, and in general we'll select the resolution is 300. The resolution is must be in at least 300. Okay. Now if we save, we'll select our location. Our location will be, I will select my location here in output and open, and our 72 maps will be exporting one by one. It will take a while. I will pause the video and fast forward the video. Okay, our map is generated. If you want to open our map, let us open our map. This is our thana map. Let's click on it, zoom out. Okay, so this is our thana name, and this is our page number 1. This is our first thana. Then it will go to the, if you scroll it down, you will see all other thana round here. So this is the answer of our fourth question, final question, that is compose an A4 size map showing the flood extent and magnitude for each upazila of eastern Bangladesh. So that's all for today. Thank you everyone for keeping your patience. We have done our project 3. We will be back with another tutorial.